Today's class is on web optics, physics higher secondary second year, and it is class number 12. Today I will specifically discuss upon the interference and fringes of only this much. And the more exciting part of the today's class is that I will just solve 11 solve pattern for NEET and JEE. The different type of the questions or the patterns asked very often from interference and fringes will be 11 types. I will solve out each and everything. So before starting these things, web optics, let me come to before that we have completed ray optics. So why web optics is needed? So to explain this, the background, I will spend only 1 minute or 2 minutes on this topic. So we have seen that when wave moves, it requires medium, but light wave does not require any medium. Why? The answer cannot be explained by ray optics. Number two, electron microscope can explain the minuscule details of an object or an atom, but the visible light microscope cannot. Why? Cannot be explained by ray optics. Again, when you view the stars of the sky with the help of telescope, we see the blurred objects of the stars. Why not distinct? That cannot be explained by ray optics. That's why we need to explain wave optics. The topic wave optics is very important because ray optics means optics may be broadly divided into geometric optics and physical optics, and geometric optics is nothing but ray optics and physical optics is nothing but wave optics. So at the very beginning, I told you that some of the questions which I put forward at the very beginning could not be explained with the help of ray optics, because in the ray optics it is assumed that ray moves in the straight. Number one, ray reflects when fall upon a reflecting surface. Number three, ray can refract it when it is placed in the refracting medium like glass or water. But when in the physical optics, that is wave optics, we see that ray does not only moves in the straight line, it diffracts, it has interferences, it has polarization, it has a lot of things. So diffraction, the phenomenon of diffraction and interference are always used in solving out the upper question which cannot be solved out by the ray optics. That's why wave optics is essential part to be learned. Now, in a very precise manner, I will just come to the interference and fringes. So before starting this one very important term, in a very short time, I will tell you phase. What is phase? In a very short way, I am just describing the term phase. Phase of a waveform is the position of a point in time in a cycle of waveform. It is position of a point in a wave in time. That is, xt is equal to xm. This is amplitude, and this is cosine equal to the omega t plus phi, where phi is a phase constant, omega is the angular frequency, and both these two add all together will give you phase. This is phase. Again, phase of motion is nothing but argument of cosine. So what is phase difference? Again, it is very simple. Difference between the phase of the two waves at a point. So that one phase displacement of one wave is equal to a equal to cos omega t, and another is equal to y2 is equal to a cos omega t plus phi. Now this is the phase omega t and this is the phase omega t plus phi. Now you make the difference of these two, you are getting phi. That is between the two displacement of the two wave, the difference of the two phase is called phase difference. Now what is path difference? Path difference means the difference in the path length at a point is called path difference, and this path difference is equal to lambda by twice pi into phi. A bit later I will tell you in details regarding path difference. It is very important because you should know this one coherent source, because upon coherence we will come to the interference term. So what is coherent? The two or more two sources are called coherent if their phase difference is same or phase difference is constant and their frequency is the same, or that sources, if the two sources are different, then they will not be coherent. Same source, the two source should be coherent if their source of origin is same. If they come out from the same source and they become two, then this will be coherent. Otherwise, two different origin of the two sources having two different origin, source of light having two different origin, will never be a coherent source. So for a coherent source, the origin of the source of light should be a single point. So interference. The term earlier we have mentioned coherent is very important for present point of discussion, interference and fringes. The phenomenon which occurs when two or more coherent sources of light interact with one another. That is, this is the source of the light, and if this source of light passes through two slits. So the origin is the same source, and they come out, this source of light coming out from S and divided into two parts of the slit S1 and S2. Then source is the single source. They will interfere after the progress of their during the progress of their propagation. They will interact with one another, and this phenomenon of interference of two coherent source, two or more than coherent source, is called interference. Now what's happened when interference occur? One displacement of a light source is represented as that gives a sine omega t plus theta not phi. Their derivation a bit lengthy. I am not showing you at this point. So that is equal to y. So finally, from the two waves we get the final wave is equal to, very important, y is equal to a sine omega t plus, and from this we can deduce s square is equal to s square is equal to finally we can derive again. I have not shown you the amplitude, total amplitude square equal to amplitude of the first wave, second wave, a twice a1 square twice a1 a2 cos of phi. Now it is known to us that intensity is proportional to a square. Intensity is proportional to a square. Therefore, I is equal to some constant into a square. So here, if you multiply all through by k, so we can write k square is equal to I, that is I is equal to I1 plus I2 twice I1 I2 cos phi. So we have got relation 1 and intensity 1, another relation. I1 plus I2 plus I1 I2 cos phi. So if I is maximum, it is very important in money to follow that cos phi should be equal to 1. Therefore, root over I1 square and this is 1. Therefore, another relation I maximum is a root over I into root over I2. So here we can write I maximum is equal to root over I1 root over I2 whole square. Similar way, if I is minimum, then cos phi should be equal to minus 1. So here we will get minus 1. So that should be minus. Therefore, I minimum is equal to root over I1 minus root over I2 whole square. Again, it is another equation. These equations are very important. Formulas are very important in solving out the 11 solve pattern of NEET. A2 square is proportional to I2. So A1 square, A2 square is equal to I1 by I2, or A1 by A2 is equal to root over I1 by I2. So another relation, A1 by A2 is equal to root over I1 by I2. We can write another equation. Root over I mean A1 by A2 whole square that is, we can write I max I mean is equal to A1 by A2 A1 minus A2 whole square, or that may be is equal to A1 by A2 plus 1 A1 by A2 minus 1 whole square, or that may equal to root over I1 I2 plus 1 root over I1 I2 minus 1 whole square. So these are very simple formulae with the help of which we will now try to solve out the element pattern. And another more example is the path difference. If it is, I am not drawing for the sake of time, if it is source, now in a very short way I have just drawing this one from the source S, the light, and the light is emitting out, and it has passed through the two slits S1 and S2 separated by distance D. And here we have, it is a screen. Here in the screen we have assumed a point P, and with respect of that point we have drawn these two lines that gives you path difference. Now what is path difference? S2P minus S1P is the path difference, and this path difference is, I have not deduced, equal to xd into d, where d is the total distance between the sources slit S1 and S2 and the screen capital D, and this d is the distance between S2 slit S and S2, and x is from the distance from the center. The S is distance from the center. The point S is the distance from the center up to this point. So the difference, path difference, is nothing but xd into d. We have not deduced it. So another point, path difference is equal to xd into d, where d is the distance between the length of the distance between S1 and S2, and capital D the distance between slit and the screen, and x is the distance between from central to the point P we have assumed. So path difference equal to sd by d. Now so we have seen for direct fringe, nth fringe always occurs as n lambda capital D by D, and for dark fringe, nth dark fringe, it is twice n minus 1, where n is equal to 1 to 3, where n equal to 0, 1 to 3. That is another formula, and fringe ut is equal to this. So beta is equal to d lambda by d. These are the sum formulae. With the help of, now we will start solving out the pattern. I am going to start with the pattern 1 of intensity. On intensity, the pattern 1 or type 1 question. So the first point of the question of the type 1, very often asked in the NEET and JEE, is the coherent source, two coherent source of the light having intensities in the ratio 2:8. Find the I maximum and I minimum. That is, you are given I1 and I2 is equal to 2 by 8 is equal to 1 by 4. That is, I1, I2 is equal to 1 by 4. A bit earlier I have told you I of maximum, that is I minimum, I1, I2, so simply you just put the value here, 1 by 4, root over 1 by 4 is equal to half, half plus 1, half plus 1, half plus 1 divided by half minus 1 whole square. This is equal to 3, this is equal to 3 square is equal to 1 is equal to none by 1. The answer is over. Very interesting, you manually follow, you can very easily understand. I have not gone through the details of the chapters theoretical parts. Now I am going to the pattern solve. I am going to solve the pattern type of the patterns 1, on intensity type 1. The intensity ratio is given 2:1. I maximum and I minimum. I maximum, I minimum equal to 2 bar I1 plus I2 plus 1 divided by 2 bar I1 I2 minus 1 whole square. I1 is equal to 1 by 4 is equal to half plus 1 half minus 1 is equal to 9 by 1. This is the first question, and question answer is over. Instantly you can do yourself, and in the mind you can do it. Now the question is again very simple. Two light sources of intensities I and 16i and phi is equal to pi. resultant intensity at the point of observation is, what is I? I is equal to I1 plus I2 plus root over I1 I2 cos phi. This is the formula I had already a bit earlier. I had written 1 I1 plus I2 equal to root over I1 plus I1 I2 cos of phi. Here the condition is that one is I, other is 16I. One is I, other is 16I plus twice I into 16I and cos pi. Cos pi is equal to minus I, because cos 90 plus 90 is equal to sin 90 is equal to minus 1. That's why we have written 17I plus twice this is equal to 4I, and that plus minus will be minus. So this is 9I. Again, it is very simple. You can do yourself very easily, very simple. You just put the intensity in two different types and go on solving this one. You will get 17I plus 8I is equal to 9I. This is the resultant intensity. You are given y1 is equal to, for one displacement y1 of the light wave is equal to y equal to 4 cos omega t, and other is y is equal to 10 cos omega t. That is nothing but amplitude. That is nothing but amplitude. That is, from the question we get amplitude is equal to a1 is equal to this, a is equal to 10. So what is a1 a2? a1 by a2 is equal to 4 by 10 is equal to 2 by 5. Am I right? I minimum, I max, I mean a1 plus a2, a1 minus a2 whole square, a1 by a2 plus 1, a1 by a2 minus 1 whole square. So a1 by a2 is equal to 2 by 5, 2 by 5 plus 2 by 5 plus 1, 2 by 5 minus 1 whole square. 5 to the 7 and is equal to 3 square, 49 by 9. Again, it is very simple. From this you find a1 and a2. We write the I maximum, I minimum in the form of a1 and a2. Just put the value, will get 49 by 4. This is type 3. The question is again, just you please go through the question. The light waves of the two lights of the intensity, one is 1 and other is I, other is 4y. They produce a fringe on the screen. They produce fringe on the screen. The phase difference at the point A is equal to pi by 2, and phase difference at point B is equal to pi. Find the difference in the amplitude of the two waves. So one A intensity difference at the points. This is the question. By the intensity difference. Now what is I? I is equal to I1 plus I2 plus twice root over I1 I2 cos phi. So for the first condition, the say it is IA at the point A, the phase difference is equal to pi by 2. So yeah, two intensities is, one is I, other is 4I plus I 4I cos pi by 2. Cos 90 is equal to 0, that is equal to 5I. Am I right? So now I of B is equal to at this case the two intensities are I and 4I, and here phi is equal to pi. So 5I plus twice I square is equal to I, and root over this is equal to 2 and cos phi is equal to minus 1. Earlier we have shown you cos pi is equal to 180, cos of 180 is equal to minus sin 90 is equal to minus 1. So what you get here is 5 pi minus 4 pi, that is equal to 1. So intensity difference at point A and B, 2 points, intensity difference, the earlier it was 5 by and now it is I at two phases, one is pi by 2, other is pi is equal to 4 pi. Again it is very simple. Type. So you are given I maximum, I minimum is equal to 144 by 81. Find the ratio of the amplitude. We know A by A1 is equal to root over I1 by I2 plus 1 root over I1 I2 minus 1, and I of maximum of this root over of this is equal to 12 by 9. So here you are getting 12 by 9 plus 1 divided by 12 by 9 minus 1 whole square. This is equal to 21 and this is equal to 3. This is equal to 7 by 1 equal to 7 is to 1. Again it is very simple. Just to write here, please go through the question. The slit of the young double slit experiment have equal width and the source. Equal source and equal widths are two slits. The slits of same source placed symmetrically to the slits at the intensity at the center fringe equal to I naught, and if the one of the source is closed, what will be the intensity of the in this point? So actually it is two identical. So we know I is equal to I1 plus I naught plus 2 over I1 I2 cos of phi. Just I am going showing you the some facts. If the two sources are identical, if two sources are the same source, identical, so no phase difference, two sources are same or identical, then I1 is equal to I2 is equal to say I naught. We are concerned with I naught. So what we get here is equal to I is equal to I naught plus twice I naught cos of phi, that is equal to twice I naught plus twice I naught cos of phi, twice I naught 1 plus cos phi equal to twice I naught twice cos square phi by 2, 4 I naught cos square phi by 2, since 1 plus cos theta is equal to twice cos square theta by 2. This is the formula. 1 plus cos theta is equal to twice cos square theta by 2. So I is equal to, our formula is, you learn it by heart. If the sources are identical, I is equal to 4 I naught cos square phi by 2. You just write this one. I is equal to 4 I naught cos square phi by 2. I have shown you. You keep it in your mind. Now the question is, the intensity at center fringe is equal to I naught. For center fringe, phi is equal to always 0. So phi 0, if phi 0 is equal to cos 0, so cos 0 is equal to 1. So solution, center fringe, for center fringe I is equal to 0, therefore I is equal to 4 I naught into 1 is equal to 4 I naught, that is I is equal to I naught. Now one of the slit is closed. Here one of the slit is closed, means the two slits has same intensity I and I. So if one slit is closed, that is the intensity is equal to I, that is the central intensity I naught is equal to 1/4 of initial intensity. So this is about the type 6. Due to the length of the class has become maximum, so I couldn't solve out next 5 type of the question surely. Within a very short time I will solve out the second 5 pattern comprising of fringes, fringe weight and part difference in my next class. Hope you have followed the class. Please don't forget to subscribe the class. Thanks a lot for watching the class.